Hello, I'm SA, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
The dawn of the semiconductor age, a period of explosive innovation following the Second World War, presented humanity with an unprecedented challenge: the industrialization of the infinitesimally small. This was not merely an amplification of existing technologies. It was the creation of entirely new paradigms for manufacturing, demanding a precision and scale that stretched the very definition of what was possible. Within this crucible of scientific discovery and nascent industrial ambition, a figure emerged whose impact would resonate through the very architecture of modern life: Andrew Grove. His journey from a young man escaping the turmoil of war-torn Europe to becoming a titan of Silicon Valley offers a compelling narrative of intellect, resilience, and a profound understanding of how to translate scientific breakthroughs into tangible, world-altering realities. Grove's arrival in the United States in 1956 marked the beginning of a career that would redefine the relationship between scientific endeavor and large-scale industrial enterprise. He stepped into a landscape where the transistor, a revolutionary invention, was still grappling with the complexities of mass production. The promise of integrated circuits, miniaturized electronic systems etched onto silicon wafers, was immense, yet the path to realizing this promise was fraught with technical hurdles and, critically, a profound lack of established managerial frameworks. The prevailing scientific ethos often emphasized individual brilliance and theoretical exploration, leaving a significant void in the systematic, disciplined approach required to build and sustain industries from the ground up. The semiconductor industry, by its very nature, was a departure from traditional manufacturing. It involved intricate chemical processes, exacting physical conditions, and a reliance on highly specialized knowledge. The creation of a single microchip demanded a sequence of operations, each with its own critical parameters and potential for failure. Controlling these processes to achieve consistent, high-yield production was a monumental task. Early efforts were often characterized by trial and error, with breakthroughs interspersed with significant setbacks. The sheer capital investment required for fabrication facilities, coupled with the rapid pace of technological evolution, meant that companies operating in this space faced constant existential pressure to perform. Grove, with his deep grounding in chemical engineering from the City College of New York and a doctorate from the University of California, Berkeley, possessed a unique vantage point. His academic training provided him with a rigorous understanding of physical and chemical principles, the bedrock upon which semiconductor technology was built. However, it was his innate ability to perceive the systemic challenges inherent in scaling these scientific principles that truly set him apart. He recognized that scientific discovery, while essential, was only one component of industrial success. The other, equally vital component was the art and science of management, the orchestration of people, processes, and resources to achieve predictable, repeatable outcomes. The problem facing companies like Fairchild Semiconductor, where Grove first applied his talents, and later Intel, was the absence of a coherent methodology for managing the entire life cycle of a complex technological product. This encompassed everything from research and development, where novel ideas were explored, to the intricate stages of manufacturing, where those ideas had to be realized with absolute fidelity, and finally to the marketplace, where these sophisticated devices would be deployed. The scientific mind might conceive of a circuit, but it was a robust managerial framework that could bring the concept to life reliably and economically on a global scale. Grove's early experiences were instrumental in shaping his perspective. He witnessed firsthand the difficulties in translating laboratory successes into commercially viable products. The transition from a working prototype to a production line capable of churning out millions of identical, flawless components was a leap that many faltered in making. This was a problem of process control, of quality assurance, and of efficient resource allocation, all domains that fell under the purview of effective management, yet were largely uncharted territory within the burgeoning high-technology sector. The scientific challenges were formidable, but the organizational and operational challenges were equally, if not more, daunting. The very act of creating a microchip involved a complex sequence of steps: wafer preparation, photolithography, etching, diffusion, and metallization, among others. Each step introduced variables that could affect the final product. Temperature, pressure, chemical concentrations, and exposure times all had to be meticulously controlled. A deviation in any one of these parameters could render an entire batch of chips unusable. This demanding environment called for a systematic approach, one that embraced data, analysis, and continuous improvement. It was a far cry from the more intuitive or serendipitous methods that had characterized earlier technological advancements. Grove's intellectual rigor, honed by his academic background, allowed him to approach these challenges with a scientist's analytical mind. He understood the importance of empirical evidence and the power of quantitative measurement. However, he also possessed a pragmatic vision, recognizing that scientific principles needed to be embedded within a robust organizational structure to yield their full potential. This dual perspective, a deep appreciation for the science coupled with a keen understanding of operational realities, positioned him to address the fundamental problem of industrializing innovation. He saw that the success of the semiconductor industry would depend not only on the ingenuity of its engineers, but also on the efficacy of its management systems. His early work at Intel, which he co-founded with Gordon Moore and Robert Noyce in 1968, provided him with a platform to begin formulating these ideas. The company was built on the promise of the microprocessor, a revolutionary concept that would eventually power the personal computer. However, bringing this complex product to market required overcoming immense manufacturing challenges. The initial vision for the microprocessor was ambitious, and its realization demanded a level of precision and control in production that was unprecedented. The problem was how to create a company culture and a set of operational procedures that could consistently produce such intricate devices, while simultaneously fostering the innovation needed to stay ahead in a rapidly evolving market. Grove's contribution in these formative years was to begin building the intellectual and operational scaffolding for this new kind of enterprise. He understood that the scientific breakthroughs that defined the semiconductor industry could only be sustained and scaled through disciplined management. This involved establishing clear objectives, defining measurable outcomes, and creating feedback loops that allowed for constant refinement of processes. The challenge was to imbue a scientific organization with a manufacturing discipline, ensuring that the pursuit of groundbreaking technology was underpinned by an unwavering commitment to operational excellence. This foundational work laid the groundwork for what would become a defining characteristic of Intel and a model for countless technology companies that followed, establishing a powerful precedent for how scientific innovation could be systematically managed for industrial success. Grove's early contributions at Intel were instrumental in shaping the company's trajectory, moving it from its nascent stages toward a dominant force in the nascent semiconductor industry. The initial focus on memory chips, particularly dynamic random access memory or DRAM, presented a fertile ground for applying his scientific rigor. He understood that the creation of reliable, high-performance electronic components was intrinsically linked to a profound understanding and meticulous control of the underlying physical and chemical processes. This era demanded a management philosophy that could bridge the gap between theoretical innovation and tangible, reproducible manufacturing. The challenges were manifold. The rapid pace of technological advancement meant that yesterday's cutting-edge product could quickly become obsolete, and the intricate nature of semiconductor fabrication required an unprecedented level of precision. Grove's insight was that a scientific approach, grounded in empirical data and systematic analysis, could provide the necessary framework for navigating this complex landscape. He began to cultivate an environment where experimentation was encouraged, but always within a structure that demanded clear objectives and measurable outcomes. This early period saw the development of management practices that would later become hallmarks of Intel's success, emphasizing a deep dive into the operational details of production and a relentless pursuit of efficiency. The semiconductor market, however, was a volatile arena. Competition in the DRAM sector intensified, with Japanese manufacturers emerging as formidable players, often leveraging superior manufacturing efficiencies. This evolving competitive dynamic necessitated a strategic reevaluation. Grove, ever the pragmatist, recognized the shifting currents and began to advocate for a decisive pivot. The company possessed a nascent but promising technology, the microprocessor. This complex integrated circuit, essentially a computer on a chip, represented a significant departure from the mass-produced, standardized memory modules. It was a product that demanded a different kind of thinking, a different approach to research and development, manufacturing, and, crucially, marketing. The microprocessor was not a commodity. It was a sophisticated engine for computation, requiring a deep understanding of its application across a wide array of potential uses. Grove's championing of the microprocessor marked a profound strategic shift for Intel. This was more than an incremental product update. It was a redefinition of the company's core identity. The transition required a fundamental rethinking of how innovation was managed and how products were brought to market. The microprocessor's complexity meant that the development cycle was longer, the design challenges more intricate, and the manufacturing processes more demanding. Intel needed to move beyond simply producing reliable components to creating sophisticated systems that could empower entirely new categories of devices. Grove understood that this pivot demanded a management philosophy that could foster creativity while simultaneously imposing the discipline required for high-volume, high-quality production. This is where the concept of the Intel Way began to crystallize. It is a management philosophy forged in the crucible of technological innovation and market competition, a synthesis of scientific principles and pragmatic business acumen. At its heart, the Intel Way was characterized by an unwavering commitment to data-driven decision-making. Every aspect of the business, from research and development to manufacturing and sales, was to be guided by empirical evidence. Grove instilled a culture where assumptions were rigorously tested, hypotheses were validated through experimentation, and performance was measured against clearly defined metrics. This created a feedback loop that allowed for continuous improvement, enabling the company to adapt quickly to new challenges and opportunities. Accountability was another cornerstone of this emerging philosophy. Grove believed in setting clear expectations and holding individuals and teams responsible for achieving them. This was not about blame, but about fostering a sense of ownership and empowering employees to take initiative. The rigorous pursuit of excellence meant that mediocrity was unacceptable, and every employee was expected to contribute to the company's collective success. This emphasis on accountability coupled with a deep respect for technical expertise, created a powerful engine for progress. The unique demands of microelectronics manufacturing provided a fertile ground for growth's application of scientific management principles. The fabrication of microprocessors involved a sequence of highly complex chemical and physical processes, each requiring precise control. Any deviation could lead to defective products, rendering entire batches unusable. Grove's background in chemical engineering provided him with a deep appreciation for the importance of process control. He recognized that the success of a high-technology manufacturing operation depended on understanding and mastering these intricate processes. This led to a focus on developing robust manufacturing techniques, establishing stringent quality control measures, and implementing systems that could monitor and adjust processes in real time. The Intel Way was, in essence, a framework for managing complexity and uncertainty. It acknowledged that the semiconductor industry was inherently unpredictable, marked by rapid technological change and intense competition. The strategy was to build an organization that could not only respond to these challenges, but also proactively shape the market. This involved a dual focus on the one hand, nurturing the creativity and innovation necessary to develop groundbreaking new products on the other, ensuring the operational discipline required to produce these products reliably and efficiently at scale. Grove's leadership during this pivotal period was instrumental in forging this distinctive corporate culture. He demonstrated that a company could be both a powerhouse of scientific discovery and a paragon of manufacturing excellence. This strategic pivot toward the microprocessor, underpinned by the development of the Intel Way, laid the foundation for the company's future dominance and established a powerful precedent for how scientific innovation could be systematically managed for sustained industrial success. The vision was clear to build a company that could not only invent the future, but also build it with unparalleled precision and efficiency. Andrew Grove's tenure at Intel marked a profound transformation in how complex technological enterprises could be managed. Following the company's pivotal shift toward the microprocessor, the challenge became maintaining the rigorous discipline required for mass production of these intricate devices while simultaneously fostering the very innovation that defined them. Grove approached this dual imperative with a mindset honed by his background in chemical engineering, a discipline inherently concerned with process control, optimization, and the predictable, repeatable execution of complex operations. He recognized that the leap from laboratory discovery to market dominance demanded an equally sophisticated approach to manufacturing and management. The problems of the time were stark. Semiconductor fabrication was, and remains, an intensely complex, multi-stage process where even microscopic deviations could render entire batches of chips unusable. Ensuring consistent quality and high yields in such an environment was a monumental undertaking. Furthermore, the rapid pace of technological advancement meant that the innovations of today would be obsolete tomorrow. Companies needed a framework that could not only produce current technology flawlessly, but also accelerate the development and implementation of future generations. Grove's insight was to apply the principles of systematic process management to every facet of the organization, transforming what could have been a chaotic, iterative development cycle into a finely tuned engine of industrial progress. Grove's unique solution was to imbue Intel with a culture of operational excellence, driven by an unwavering focus on process. This wasn't merely about quality control in the traditional sense. It was about understanding, quantifying, and continuously improving every step in the value chain. He championed the idea that management itself was a process, one that required clear objectives, rigorous measurement, and constant feedback. This philosophy manifested in several key areas. First, the development of sophisticated manufacturing process control techniques became paramount. Grove understood that to achieve predictable outcomes, the variables within the manufacturing environment had to be meticulously understood and managed. This involved detailed statistical analysis of production data, identifying sources of variation, and implementing corrective actions to minimize them. The goal was to move beyond reactive problem solving to proactive prevention, ensuring that defects were designed out of the process rather than being discovered and addressed after the fact. A critical element of this approach was the emphasis on metrics and feedback loops. Grove believed that what could be measured could be managed and improved. Every aspect of the business, from wafer fabrication yields to employee productivity, was subjected to scrutiny through quantifiable data. This data then informed decision-making, creating a continuous cycle of assessment, action, and refinement. This data-driven ethos permeated the company, fostering an environment where objective evidence, rather than subjective opinion, guided progress. The concept of the product process matrix, while a broader industrial concept, found a powerful practical application under Grove's leadership. This framework acknowledges that the optimal manufacturing process for a given product depends on the product's stage of development and its market volume. For early stage, low volume products, flexibility and rapid iteration are key. As products mature and scale, the focus shifts to efficiency, cost reduction, and yield optimization. Grove ensured Intel's operations were aligned with these principles, adapting its processes as its products evolved. Grove also popularized, and perhaps more importantly, operationalized the idea of management by walking around. This was not about idle observation, but a deliberate strategy for data gathering and problem identification. By being present on the factory floor and in various departments, Grove and his managers could gain first-hand insights into operational challenges, identify bottlenecks, and foster direct communication. This direct engagement provided a crucial complement to the quantitative data, offering qualitative context and surfacing issues that might not be apparent through numerical analysis alone. It fostered a sense of shared responsibility and encouraged employees at all levels to identify and report problems without fear of reprisal. This was intrinsically linked to a culture that embraced constructive confrontation, a concept central to Grove's philosophy. He believed that open, direct, and often vigorous debate about problems and solutions was essential for progress. This meant that disagreements were not to be avoided but channeled constructively, leading to better outcomes through rigorous examination. The influence of these process-oriented strategies extends far beyond the confines of the semiconductor industry. Grove's systematic approach to quality and innovation became a blueprint for operational excellence in manufacturing globally. His insistence on data-driven decision-making and continuous improvement laid the groundwork for methodologies that would later be formalized as total quality management (TQM) and lean manufacturing. The emphasis on understanding and controlling complex processes, the reliance on feedback loops to drive refinement, and the cultivation of a culture that welcomed rigorous problem-solving are all hallmarks of modern industrial best practices. These principles are still taught and applied today in fields as diverse as automotive manufacturing, aerospace, and even software development, demonstrating the enduring power of Grove's vision. His work at Intel solidified the understanding that scientific breakthroughs require equally robust management systems to translate them into tangible, market-defining products, establishing a paradigm for how innovation could be systematically nurtured and scaled. Andrew Grove's influence extends profoundly beyond the intricate engineering of microprocessors and the meticulous orchestration of manufacturing processes. His enduring legacy resides in the philosophical underpinnings of his leadership, a framework that continues to guide organizations grappling with the relentless currents of technological evolution and market volatility. The persistent challenge for any leader is to navigate environments characterized by rapid change, where established paradigms are constantly being reevaluated and disrupted. Grove offered a compelling solution, articulated with stark clarity in his seminal work, High Output Management. This book, far from being a mere operational manual, serves as a testament to his deeply held beliefs about how to achieve sustained success in complex, dynamic systems. Grove's insistence on clear objectives, epitomized by the rigorous application of management by objectives, provided a vital anchor. This was not simply about setting goals. It was about instilling a pervasive sense of purpose and accountability throughout an organization. The notion that every individual and every team should understand their contribution to the overarching mission remains a cornerstone of effective leadership. This clarity, when coupled with robust metrics and regular evaluation, empowered individuals while simultaneously ensuring organizational alignment. The emphasis on measurable outcomes fostered a culture where performance was transparent and where the pursuit of excellence was a shared endeavor. Furthermore, Grove championed the idea that leaders, even those whose primary responsibilities lie in strategic direction and human capital management, ought to possess a fundamental grasp of the technical underpinnings of their enterprise. This perspective challenged the prevailing notion of a purely managerial class detached from the technical realities of production. Grove understood that genuine insight into an organization's capabilities and limitations and the ability to anticipate future technological trajectories stemmed from a deep, albeit applied, technical fluency. This intellectual curiosity and willingness to engage with the granular details of engineering and product development allowed him to make more informed decisions, foster more meaningful dialogue with his technical teams, and ultimately to steer Intel with a surer hand through uncharted territory. His philosophy underscored the critical importance of adaptability. In a world where innovation is a constant, organizations must cultivate an inherent capacity for change, not as an occasional necessity, but as a perpetual state of being. Grove's management principles foster this by emphasizing rigorous analysis, a willingness to question existing assumptions, and a commitment to iterative improvement. The concept of radical transparency in performance and process, while demanding, created an environment where problems were identified and addressed swiftly, preventing them from festering and undermining progress. This proactive approach to problem solving, rooted in a deep understanding of systems and feedback loops, allowed Intel to pivot and adapt with remarkable agility. Grove's approach to management was fundamentally about building resilient organizations. Resilience, in his view, was not an inherent trait but a cultivated outcome, forged through disciplined execution, unwavering focus, and a profound understanding of the competitive landscape. He understood that true competitive advantage lay not merely in superior technology, but in the superior management of that technology and the human capital that brought it to life. His writings and his tenure at Intel provide a powerful case study in how a leader can instill a culture of high performance, demanding excellence, without sacrificing the human element and fostering an environment where individuals are empowered to contribute their best. The principles Grove espoused are remarkably timeless. In an era increasingly defined by rapid technological disruption, the challenge of leading with clarity, fostering adaptability, and maintaining a deep understanding of one's domain is more acute than ever. His emphasis on accountability, on setting clear expectations, and on the leader's role in driving performance continues to resonate. The lessons gleaned from his experiences at Intel offer a profound guide for anyone seeking to build and sustain successful organizations in the 21st century. Gross' legacy is that of a builder, not only of silicon chips, but of organizational structures and philosophies that enable sustained human achievement. His work remains a foundational text for understanding how to lead effectively through complexity, a testament to a mind that saw the intricate dance between technology, people, and purpose.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.